What if your DNA could whisper stories from 40,000 years ago, before kings, before writing, before civilization itself? For millions of Europeans today, it can. Because hidden deep in the maternal code of your mitochondria lies one of humanity's oldest surviving lineages, Haplogroup U5. Unlike most of your DNA, which comes from both parents, mitochondrial DNA, or mtDNA, is passed down only from mother to child. That means every human alive today carries a small, unbroken line of maternal inheritance that stretches back tens of thousands of years. And for Europe, that line begins with U5, a genetic signature so ancient, scientists call it the mother of Europe. Haplogroup U5 was born somewhere between 35,000 and 45,000 years ago, in the depths of the last ice age. This was a world of woolly mammoths, cave lions, and endless glaciers, a time when survival depended on firelight, tools, and the strength of small tribes scattered across a frozen continent. To trace U5, scientists turned to ancient bones. In 2015, mitochondrial DNA extracted from the remains of European hunter-gatherers, people living long before farming existed, revealed a striking fact: many of them belonged to haplogroup U5. That means that before agriculture, before the Neolithic Revolution, before Indo-European migrations reshaped the continent, U5 women were already there, raising families, migrating with herds, and enduring through the harshest ages nature ever offered. These were not the descendants of farmers from the Middle East, or metal workers from Anatolia. They were the original Europeans, the first mothers of the continent. Imagine Europe during the Ice Age. Forests covered the south, tundra stretched northward, and glaciers towered over what is now Germany and Scandinavia. Tribes moved with the rhythm of the seasons, following rivers and animals. Among them were women carrying the U5 mitochondrial line. Each child born carried her code forward, each generation a living continuation of the Ice Age. When scientists compared ancient DNA from across Europe, from Spain to Ukraine, they noticed something fascinating. U5 was everywhere. Even after massive migrations and population changes, traces of this lineage remained. It was like a faint echo of the first mothers that refused to fade. U5's story is not just one of origin, but of survival. During the harshest glacial periods, many populations vanished or retreated into southern refuges: Spain, Italy, the Balkans. But U5 women survived. Their descendants slowly spread back north as the ice melted, repopulating the continent. To scientists, this persistence makes U5 a marker of resilience. These women survived starvation, disease, and climate catastrophe. And their descendants would later witness the dawn of everything we call civilization. So, around 9,000 years ago, something new arrived in Europe. Farmers from Anatolia and the Near East. They brought domesticated crops, pottery, and honestly, a completely different way of life. Their mitochondrial DNA looked different, belonging mostly to haplogroups like H, J, and T. At first, geneticists thought these Neolithic farmers replaced the hunter-gatherers completely. But then, buried deep in ancient remains, they found the truth. U5 survived. Even as the continent's culture changed, the ancient maternal lines remained. It turns out, the descendants of those Ice Age women intermarried with the newcomers, blending the old and the new. That's why even today, U5 makes up about 5 to 7% of the mitochondrial DNA across modern Europe, especially in Scandinavia, Finland, and the Baltic regions. The highest concentrations of U5 are found among the Sami people of Northern Europe, often called Europe's last indigenous population. Their genetic code is like a time capsule, preserving both U5 and ancient DNA markers rarely found elsewhere. It's no coincidence. The Sami are direct cultural descendants of Ice Age hunter-gatherers, who never fully assimilated into agricultural Europe. Through them, we can, really glimpse the endurance of one of humanity's earliest maternal lines. But U5 isn't confined to Europe. It has been found in surprising places. North Africa, the Middle East, and even Siberia. Evidence of ancient migrations and interconnections that predate history itself. Some scientists believe U5 may have played a key role in the genetic exchange between early Europeans and Northern Asian populations, linking people separated by thousands of miles through shared maternal ancestry. Every sequence of U5 DNA tells a slightly different story. Some trace to Ice Age Italy, others to ancient Russia, and others to the first Baltic hunters. But all share the same ancient mother, whose lineage, well, never broke. So, how do scientists trace such ancient ancestry? Well, the answer lies in mitochondrial mutations. These are tiny changes that occur every few generations. By measuring and comparing these mutations in both living and ancient samples, geneticists can estimate how old a lineage is and where it branched off, which is pretty fascinating. Now, in the case of U5, researchers estimate it arose shortly after humans entered Europe from the Near East. This means its roots lie with the very first modern humans to settle the continent permanently. That's why U5 is often seen as Europe's founding maternal DNA. It's amazing how much we can learn from these tiny changes, isn't it? One question continues to fascinate scientists: why did U5 survive when so many ancient haplogroups disappeared? The answer may lie in adaptability. Studies suggest U5 carriers may have had metabolic advantages suited for colder climates, more efficient fat storage and energy usage. These traits would have been life-saving during Ice Age scarcity. In other words, natural selection might have favored U5 women and their children, making them more likely to survive and pass on their genes. There's something honestly kind of poetic about U5. It's not a warrior's gene or the mark of empires. It's maternal, quiet, enduring. It tells a story not of conquest, but of continuity. Of mothers who endured when the world nearly froze. For anyone who carries this lineage, your mitochondrial DNA is a direct, unbroken line to a woman who lived in a prehistoric world. She saw the glow of Ice Age fires, heard the calls of mammoths, and looked up at the same stars you see today. And through every generation since, her DNA has whispered the same message: we survived. If you've taken a DNA test and discovered you carry Haplogroup U5, you are part of one of the oldest human lineages still alive today. It connects you to a chapter of history written long before civilization, religion, or nations. Even if you don't, U5 still lives in your neighbors, your friends, your community. A reminder that all of Europe's diversity springs from shared ancestral roots. Because the story of U5 isn't just a genetic map, it's a human one. In the end, U5 reminds us that progress didn't erase the past, it built upon it. When we look at the modern world, our cities, our art, our science, we are looking at the distant descendants of women who refused to vanish into the snow. Haplogroup U5 is not just a code in a cell. It's proof that endurance, adaptability, and the strength of mothers are the true engines of human history. And as long as a single strand of their DNA survives, their story will never end.